So that looks better. Let's see whether something happens here. Yeah! So, who we are. We start with the agenda. Let's speed up things since we lost some time. A short word about the target audience, benefits of using version control, introduction to the Git concept, workflows, and last but not least, we want to give you something how you can add Git to your life. So we start with the introduction. I'm Deputy Team Leader of the Client Services at the university. We provide services for Mac, Linux, and Windows, and Balz's System Specialist for Mac and Linux. So our alma mater was founded some 550 years ago. We're talking about 3,000 full-time equivalents of employees. That's about 1,300 people in administration, including us as service providers. About 13,000 students, and we have 7 faculties, 29 departments. And fun fact, it's spread all over the city of Basel at roughly 90 sites. So we also have some service hubs, 5 so-called service centers, and without them we would be helpless. They enable us to provide our managed clients. Yeah, target audience. We wanted to do a little disclaimer. When we had our talk in mind, we were shaping it for system administrators. So scripts, small work groups, small projects, that we had in mind. It's not targeted at heavy software development. And another thing, there are of course a lot of version control systems out there besides Git, but we don't have any experience with them. So that's the reason why we cannot say anything about them. That's no judgment at all. Benefits. So this is a fun fact, benefits. Why should you use a version control system? And yeah, we thought to put it in one juicy line, it enables you to do the coolest thing on earth on a computer. It allows you to travel in time. Okay, we have to specify that a little bit. Version control is a big expression, but when it comes down to a simple thing, it's like you do a lot of versions by yourself. You not even notice it. When we sat into a hotel room yesterday, we have about, I think, 6 different versions of this talk. So you start some work, you start some coding, you sleep over it, and then you think, I can do something better. There you have version 2. And then maybe a colleague says, oh, well, I have another idea how to implement that role in Ansible or whatsoever, and then you have version 3. And after some time, you go back in time because version 2 was really the best version. So you see in our everyday life, there is traveling in time already, and Git supports that. And that's the cool thing. Of course, in fact, every version of your code is available to you at any time. You can see the changes, and you can undo changes. And it enables you to have dedicated tasks for development, for testing, production. You can communicate your changes through commit messages. And share code, not with yourself, but also with other people, so it's called collaboration. So that's cool. How about the concept? The Git concept, we also put some thought in that. And we thought, how could we learn about a thing we don't really know yet? And we came up with the solution. We said, let's build it by our own. We would learn a lot by trying to build it by ourselves. So on the following slides, we have that approach. We try to explain Git by implementing full functionality by ourselves, like visiting, reloading, going to different versions of your work, like a little homemade version control system. And we just pretend there is no Git. And we compared that homemade version control approach to what Git provides you with. So let's start simple, readable. We're not the first ones coming up with this idea. The idea is based on an idea from John Preston Werner. And basically we start with doing snapshots. You start working on something, you have a couple of files, and then you decide, that's an interesting state. let's do a snapshot. You start doing a folder, you call it snapshot 1, and you put all your work in it. And after some further time, you put some work in there, say, yeah, that's also good. Let's save that state 2, maybe it's coming in handy later. Let's do a snapshot 2, 3, and so on. And then you have a lot of snapshots of your work. And that's more or less like the same, like different versions. You can go back and forth. So every snapshot contains all your work you've done. And you have a little inventory, of course. You do a little message.txt file. You put it in all your snapshots. And it has some information about the snapshot. The first one, of course, initial setup. Maybe in the second one, I implemented feature X, Y, Z, and so on. So we set up this little homemade version control system by just copying stuff into our folders. How do we get started with Git? First thing we do is we do git init. And hooray! Of course, terminal. Something is not right. You have to do something. Go away. No. There's also a little prompt here. You need to install the command line developer tools first. So please push that button, because if you click on that, it takes a long time to install the whole Xcode. And what have you got after that? First you see nothing, and then you dig a little bit, and you've got one hidden folder, .git, and there's a lot of stuff in it. And in this folder, more or less, Git lives in this folder. So if you want to get rid of Git again, just remove that folder. All your versions are gone. You're just left, of course, with the last bit of your work, but that would be a way to get rid of it. We have to do some further setup, because in collaboration and in version control, the author is important. So we want to set the author. You can use these commands to globally set the name of the user and its email address. And of course, you can do this on a per project basis too, just without -global. And you can check your configuration with git config-list. So what have we got? We've got all these folders in our homemade version control system. And we just dragged and dropped the files, and of course, easy, we got the copies, we got the backups. What do we do with Git? In Git, we have to start doing a git add file. But yeah, Git is more granular about taking snapshots. So there are more areas. You have one working area, you have one staging area, and you have a local repo. And only the local repo is really what you can compare to a complete snapshot. So there is tracked files and untracked files, of course unmodified and modified files. And Git is clever. When you edit a file, it automatically detects, okay, this file is of course modified. So we do a git add, and that puts just that file into the staging area. It's tracked afterwards. You can directly use git add for an untracked file. And to check on the status, of course, there is a command git status. So that's good, but sometimes you don't want to track something. And there is git ignore. And that prevents you from accidentally adding files with sensitive data or bloating your repo with big binary files. And that file is called .gitignore. And all that it does, it defines a pattern, and all files that match that pattern defined in .gitignore, they will be ignored. So you're safe on that side. And of course, you don't have to invent this list again and again. There's a very excellent selection of gitignore files at GitHub, and it's ordered by programming languages. So let's have a look at an example. For example, we start with a README file. We just edit that file, and then let's have a look with git status. And in red, you see, okay, there's an untracked file. So let's add that file. In fact, we do a git add dot to add everything in that directory. And again, we do a status, and now it's tracked. There's a new file. Wonderful. But still, this is just put into the staging area. It's not a snapshot yet. More about that from Blaz.
Thank you very much. The reason why we spend so much time on this distinction between your working area, your staging area, and your actual your snapshots or commits, as Git calls them, is because there is not really a GUI equivalent for the staging area. When you go about your business and sort of run your snapshot-based your snapshot-based version control, you just add files and that's it. But you don't have a real GUI equivalent of the staging area. You can think of it as sort of yet another folder where you put things that you later want to snapshot. And you do this with Git by just using the git commit command. But unlike with our GUI example, where you can skip the part of writing a text, a description of your individual snapshots, it actually enforces you to write something at least. So if you type git commit, your text editor will open, and if you don't write anything, the commit will be aborted. You can speed up these steps here if you already know that you want to include all the tracked files in a commit. You can just add the -a command, which sort of expands to commit all the tracked files. And if you have a simple commit and you only require a simple commit message, you can supply the -m command and then just type your git commit message on the command line. But more complex commits require more complex or more evolved commit messages. So if you just type git commit, it brings you to your text editor. By default, this is the system's default editor, which usually is Vim, but you can also edit this and add the text editor that you're the most comfortable with, Atom in this example. Just remember, when you are using a GUI editor, you have to pass in the wait option as well to tell Git that it should actually wait for the input from that program, because otherwise it will just open the editor, don't find a commit message, and then abort because you didn't provide anything. So wait is important in that case. Okay, now you can edit your commit messages in a way you're comfortable. But what should you actually write? What is actually meaningful when you come back to a project down the line, a week or a month later? Just by the way, git log is the command you use to list all these commit messages. And a gentleman by the name Chris Beans, he has an excellent blog post about about git commit message best practices. And he starts out by showing you how not to do it. He has a git log command. You can see here that you can pass some parameters to it. There's the --1 line option, which will just display the first line of a commit message or of a commit, because otherwise they can be quite verbose. You can also pass in a number to limit the output to, in this case, the five first entries, and you can narrow down your analysis of your code or of your history further by supplying an author and a date as well. This is a command you could run maybe when you come back from holidays and you want to see what your colleagues have been up to. You just want to know, well, what happened in that time after my holidays. But you can see this is probably not ideal. You see that some of the commit messages, the first two, for example, are too long, so they get cut off. You can see that some of them start uppercase, some start lowercase, which can be annoying if you read through 10 or 20 of these. And there's the very uninformative command or commit message polishing. Well, that doesn't tell us anything, so we have to go into the actual commit and see what has changed. Down the line, there's the better example. You can see here that all the messages now have a size that isn't cut off with the one-line option. They all start in uppercase and they all start with a verb, and the disk polish commit message gives us more information about what has actually been polished. So we can sort of sum up these best practices that the first line of your commit message should start with a verb. It should be less than 50 characters. Should be 50 characters or less. You can always continue on the next lines. This is just for so that the overview gets displayed properly. And the core of this really is that a well-crafted Git commit message is the best way to communicate a context about a change. The git diff command, which is a command we'll get into in just a second, that can tell you what changed on a per commit basis. So it shows you the code changes. But sometimes there's more than one option, and the code doesn't tell you why option A has been chosen over option B. You have to have a commit message for this. And this will also help you to keep you and your coworkers happy by giving them the reasons for your actions and not just the actions themselves. And in addition, if you happen to use an outside tool, an issue tracker of some sort, you can also add a short reference to that issue number in your commit message on the first line, and this way you can just type git log --1 line, and you'll see all the different issues and where to look further for additional information. So what do we have so far for our Git workflow? We can type git status to see which files are in which state, which are changed, which are not yet tracked. You can then add the files you want to include in a certain snapshot, and then you can type git commit to commit this. But there's more, and there's one thing where I initially struggled with when using Git, and that is that the way Git tracks files means that a file can have different versions in different areas at the same time. So a typical case that can happen is if you already committed a file, which means there is an existing commit with a version of that file. So it is actually represented more than once. It is in your project history, in your commits, and it's also in your working directory as a unmodified file. And then if you continue and modify that file, it just moves over from being unmodified to modified. That's fine. We then use git add to add it to the staging area, and then we realize, well, that change isn't good enough. We have to supply something else, or we forget that we staged that file and continue our work. So this means that our file is actually represented in three different places at the same time. Let's look at what this looks like in practice. Here's a very simple example with a file that just says hello world. We have already committed this to our snapshot. We did a commit already. So if we type git status, it doesn't show us anything. We then edit that file and run git diff, which shows us the difference between our last commit and our working directory, and we can see what line we changed. We then say, oh, we're happy with that change. That is great. We're going to add it to our staging area, and then we're going to run git status again to say, well, now it's in the staging area. That's fine. But then we find a way to improve on our work, and when we run git status now, we can see that the file is actually presented in two places. It's a change to be committed, and it's a change not staged for a commit. And this can happen quite often, and just don't let it confuse you. When you run git diff --staged, you will actually see the difference between the changes you're about to commit, the changes in your staging area, and the version in your last snapshot, or in your last commit. And so this is the file you added to your staging area, and if you run git diff without an additional parameter, you will see the difference between the file you have in your working directory and the file you staged. So really, it can be confusing, but it's actually quite straightforward. You just have now at least three different versions of your file that Git knows about. You can then go ahead and just say, well, that is fine. I'm going to commit the version I staged, and then I'm going to do another commit afterwards. Or you can add the new version of the file overwriting the other one in your staging area. And by the way, if you added files to your staging area that don't belong there for this commit, you can just use git reset to remove them from the staging area. If you worked on 3-4 different files and you want to include just 2 of them for your for this commit to make it clear what you're trying to achieve with that commit. And if you excuse me, and if you screwed up and if you would like to recover an older version of your file, you can just do a git checkout of that file, and this will give you the last snapshotted version of this file, overwriting the work you did in your working directory. So what does this give us? It gives us git status to run to see what files changed. It gives us git diff to see what actually changed inside these files. Then we can add the files we want and we can commit them. And if we commit often enough, we might want to do a release, and Mike will tell you more about that.
Thank you, Blaz. So, at a certain point, you're happy with your Ansible role or your script in Jamf or whatever work you're tracking. And yeah, you want to keep track of your releases too. So in our homemade system, we just put there another text file. We name it release.1. And in this text file, we just note down on what snapshot that release is based. In our example, it's snapshot 15 we released. And that's it. So why not? Take it simple. Now, what's the equivalent for that in Git? We would do a git tag -a to achieve the same thing. And yes, of course, if we load snapshots into our working space and load other snapshots in our working space, it would come in handy if we also keep track of our main line. So we add another text file in our homemade system. We just call it main.text. And we said, okay, right now we are working with snapshot 17. Everything's good. But then, of course, there's this bug fix. Real life shows that some errors are only found in production. And of course, you start with this wonderful call, a ticket that a bug is found. And okay, you'll check with your snapshot. And let's have a look at that .release file, and you say, okay, what I released last time was the release 1, and it's based on snapshot 15. Wonderful. I just load snapshot 15, look at the bug. It's really easy. You just correct that mistake, save the whole thing as snapshot 18, and you're done. Wonderful. But wait. Now you have to rethink your naming convention on snapshots, because before that happened, you had a wonderful sequence. You knew that snapshot 12 was based on snapshot 11. That was easy, but now you have snapshot 18 on the new release, and it's based on snapshot 15. So in your old logic, it would be 17. That's not working anymore. But hey, hooray! IT has a solution for everything. Let's do it with the concept of a tree. The tree concept gives you that. You can always find your predecessor. Like when you're at bugfix 6, you can find your way back with the tree to bugfix 5. Or if you are at the branch main, you are at 4, and you can find your way back to the next node before, like 3. And in our case, where we have the bugfix branch, we know that in that tree, the predecessor is 3. So you can always find your way back. So hooray! We'll do the tree concept. And how do we do that? By simply noting down what's the parent of that snapshot. And it's rather easy to implement that in our homemade system. We just add that information in our text message file. Parent snapshot of that snapshot 18 is 15. Hooray! And with the concept of trees, of course, there's the concept of branches involved in that. And we have these 2 branches right now in our example, the main branch and bugfix branch with the release tags. Of course, everything's good, life's great. And then you realize And mistakes we did in the bug fix and fixed in the bug fix, they should be also corrected in main. So let's merge those. And then this is the moment where you again have to rethink your concept, because what would happen if you would do it that way? All the additional options maybe in your Ansible role or in your scripts you implemented in the new main working area, they would be given out there for free when you just merge these two branches. So, okay, we don't want to do that, but hooray, we have a tool that allows us to travel in time, so we go back. We go even back one step further. Solution is, like best practice, just open for every feature in a branch. Let's open a new branch for bug fixes. And in that way, you can just merge the bug fixes with your main branch without giving away the features. So stay in control, make a new branch for new features. What are the commands you would use in Git to do that? There is, of course, the command git branch with the respective name. And if you want to load a branch into your working area, it's git checkout with the respective name. That was just the beginning. Blaz will continue to dig into that further.
Okay, now we'll get a little more technical, but don't worry, this is just a slide to show you how Git represents data internally. You can see on the right that every file is represented as a blob with a checksum. These are then parts of the of a tree structure, which is the actual snapshot for each commit, and then the pointer of the individual commit. If we zoom out a little further, we can see that every commit is pointing to a snapshot and to its respective parent. Git really likes pointers, so many of the key features are implemented as pointers, and you can see here tags and branches and the equivalent to our main.txt, so the version that we are right now working on, that is called head in Git. That is a pointer as well, and this makes branching very, very easy and very, very cheap from a resource point of view, because all that is really happening when you type git branch and then a branch name is that a new pointer is created. And then you have your head pointer, which sort of determines the content of your working directory, and all that you do is when you check out another version is that this head pointer is pointing to another of these branch pointers. It is important to note that as you move on and as you do more work on one of these branches, checking out a different version will actually alter the content of your working directory, as Git will add and remove files depending on what state they are in this current snapshot. And as it is, if you do a lot of branching, which Git encourages you to do, you'll also have to do some merging eventually. And when I started out using Git, I was quite scared of doing merges, because I've been told they are terrible and they are very difficult. And every time I saw a message like this one, I was really considering just moving the work I wanted to include somewhere else, burn down the Git repo and start over. But when we look at what merges actually are on the file level or on this pointer level, it gets easier to comprehend. So this is our example from earlier. We have our stable master branch, and we have some work we did in testing, and we would like to include this into our master branch. All we have to do here is check out the relevant branch we want to merge into, and then tell Git which branch or which pointer at this point we want to include. In this case, you can see the branching is really straightforward. All Git has to do is move the master pointer, which is currently pointing at one commit, just move it further ahead to point to the commit testing is pointing at. This is called a so-called fast forward merge, because all Git has to do is, well, it's obvious, it just has to move fast forward. But most cases are not this simple. This is a much more common case. You you do a branch and you do some work on it. In this case, it's the issue 53. And while you were working on this one, the master is changed as well. This might be because a bug fix arrived and had to be merged, or because of a plethora of reasons. And when you, in this case, which is a very common case of merging, what Git will try to do is it has the snapshot you want to merge into. This is our commit 4. It knows what you want to merge in. It's the content of snapshot 5. And it knows the first common ancestor, which in this case is snapshot 2. And what it will do is it will create a new commit incorporating changes from the other commits. It can do this automatically, or it will prompt you for interaction. But I think this is an important thing. You will create in the end a merge is just another commit in this history. So next time you see this message, don't panic like I did, but ask Git nicely what the status is. And Git will actually tell you all you need to know. It tells you which files have been modified in both branches, and which couldn't be resolved automatically. It will tell you that you have it's unmerged, and you can either run git commit to continue, or you can run git merge abort to go back and reconsider your life choices. And it even tells you exactly what you have to do. It tells you use git add and then the file name to mark that conflict as resolved. So let's do this. And this is a very simple case. Michael and I were working on a screenplay here. It has a lot of potential, but we don't know what direction this character should evolve into. And you can see here that Git was kind enough to annotate the file with the conflicting versions. You can see we both changed the same line. And now it really helps me to know, well, it's going to be another commit in my Git history no matter what I do. So I can go ahead and resolve this conflict in any way I see fit. Then add this file to my staging area and run git commit, and to enter my text editor and to write a meaningful commit message about why I did resolve this merge conflict in this way. Some things we found useful in working with branches and merges is to have a master branch or a branch that is always stable, so you know which branch to deploy from when you check out your scripts or your tools, and to work on feature branches as often as possible. That helps you to not only to separate development more clearly, but also it helps you to think about what you actually want to do in this dedicated branch, and you're not all over the place with, well, I want to do a bug fix, but I also want to do a feature. Well, yeah, just do that, but do that in dedicated branches. The last thing here is that we use pull requests wherever possible. Pull requests are not a feature of Git, but rather a feature that is built on top of Git, and which is implemented by all the well-known sort of Git server platforms like GitHub, GitLab, and Bitbucket, and so on. So in order to use those and to collaborate with others, we have to talk about remotes. And if you want to set up such a remote to share code to commit there, the example of GitHub is quite straightforward. You just say, well, I'm going to add a new repo. You choose whether it should be public or private, and the name as well. And then GitHub will exactly tell you what you have to do. So we'll just go ahead and do that and look into what we created. We have now a remote repository with, let's say we have the branches master and testing. They're called origin here, and we'll hear more about that in a second. And now if I want to contribute to this repository, all I will do is I'll run git clone with the respective URL, and this will set up a local repository for me with my branches master and testing, and I can use git push to push my changes to a remote repository, and I can use git pull to pull down changes. If this is your sort of your standard Git workflow, the way you interact with Git, then you will probably assume that the remote repository is always called origin, that the first branch is always called master, and that there is no difference between master and origin/master, that they are the same. But these are actually all Git conventions. There's no reason why the remote should be called origin or your branch should be called master. And one thing I blame for that confusion is that the local repository is never referred to by name, so it's not. So when you look at your branches, and it's never a local/master and versus origin/master, but it's always master versus origin master. So keep that in mind. These are not the same. The way Git Clone sets it up for you makes it appear like this is the same, but it is not. And you also can have several remote repositories. You might have a workflow where it makes sense to have a repository where your development happens, and you want to push releases then to another repository. This might complicate your workflow, but it might make sense in your situation. And also branches can be called whatever you like. There's no reason that they should be called master. Okay, now what does happen when I run Git Clone and the URL of my repository? This is actually shorthand for several commands. This will create a directory and the corresponding Git repository, in this case just an empty one. It will then add the remote repository as with the short or with the alias origin, but you could really add or write anything you wanted. This is just a name for your local repository to refer to the remote, and you can give it a more meaningful name if you want to. And then all the pointers from this remote repository are loaded onto your machine. You'll remember a few slides back, basically everything in Git is a pointer pointing to a commit, which itself is pointing to a snapshot. So these pointers that are fetched here, you cannot edit them, but you have to merge them into your local branches and edit this, and then use git push to update the remote repository. And there's a short for this as well. If you say you want to git check out a new branch, you tell it the name of this branch should be master, and you should track origin master. So that's the short overview over remotes. If you want to continue, I would really encourage you to have a look at one of these getting started pages from these are sort of the three big Git hosting services or I know, as well as the last one. This is just a link to the Git project website, and there's a free book which is quite informative and which will tell you more about Git workflows and the inner workings of Git in general. And then last but not least, if you want to work with Git, you need machine-readable files to have something to track. If you have to build packages, there's the great AutoPKG, but there is also a project by Greg Nagel, the creator of Monkey, which allows you to write in code the exact steps to create a PKG file, and there's the more makefile-oriented the luggage. You can also add Git to your shell with a tab completion and with a nice program that will show you the branches you're on. You're not supposed to remember the URLs, you'll get the slides afterwards. And the gentleman who was speaking in this room before us, Jeff Lee, he wrote a nice tool to leverage the Jamf API to have sort of a release cycle for scripts you want to publish on your Jamf instance. And last but not least, if you want to write down a description of your infrastructure as code, that is a very nice way to do releases for the configuration of your whole fleet as well. There are several tools available for this, and at the conference there are people who use some of these. Puppet is very popular. There's a workshop about Chef tomorrow morning. I know of people who use SaltStack as well, and we use Ansible, and we did a little talk last MechaDuck about how we do this. So that's really all from our side. Thank you very much. And are there any questions?
What about the security of when you're not just a person like you with your laptop and you're logging onto Git? I assume there's two-factor if you're logging by the web. What if your laptop is just emitting code? Is there any
when you a Git remote is usually a Git server such as GitHub, and the usual protocol that people use is SSH. So you authenticate with your key there.
You can also generate a token from GitHub, which is based off your two-factor authentication, and then you just provide that token with a good password with your
Does this work on the command line as well? Because I noticed when you have two-factor enabled and you want to You want to use basic authentication. That was not supported last time I checked.
Okay, but you can generate a one-time.
But the token is a better idea anyways.
That every time.
Any more questions? Or
just one last question about security?
Sure.
If they weren't doing that, and does it have a brute force protection if someone's out there just trying to hammer your Git? Because there's a lot of breaches with Git. Is there any way I just brute force your account and just keep trying it until I get your password? Is it just lock out?
I think you can disable. I mean, they really encourage you to use two-factor, but I can only talk about GitHub. I don't know don't know about the other ones. And you can also, I think you can force some checkouts only be available through SSH, which is quite safe. So I think there's no perfect answer to that, but it sort of goes in the right direction. But that is not a Git sort of a Git problem, but it's more of a thing that the hosting the website where you're hosting your Git repo on has to look at. Because you can just have your local repository and use that and never add a remote repository.
On-premise where you don't have to use GitHub, you just Blaz and Stash. There's various providers. For a small organization hosting Stash on front. It doesn't have to be a web service. So,
I think. Okay, any more questions? Okay, thank you very much for your attention.